Yesterday we have learned about organic chemistry introduction. Now we are going to learn about isomerism. Isomerism. What is isomerism? Isomerism means which have the organic compounds which have same molecular formula but different structural formulas or rotationally different or orientation different formulas. These are called as isomers. Now isomers are divided into two: structural isomers and stereoisomers. Now, what are structural isomers? Structural isomers are those which the molecular formula only differ in structures, that is chain or position or functional. These are chain isomers, position isomers, and functional isomers. What about chain isomers? Let's talk about chain isomers. Chain isomers. These chain isomers are meant as whenever a carbon chain is written like this: 1, 2, 3, 4, 5, 6, C6, then it is hexane, right? Then in how many ways this formula can be written? This formula is H3, H2, 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 H3, C6, H14. This is having same molecular formula. Then what about the structures? First structure, second structure is this is one structure, this is one structure, this is one structure. Like this, we have same molecular formula but for all these four, but we have different structural formulas. This is called as chain isomers. Now, what is meant by position isomers? Position isomers. Position isomers are meant as, we have learnt yesterday about double bond, triple bond, right? In that, see, if you have written like this, this is called as 2-butene, right? Then what about its position isomers? Its position isomer is CH2 double bond CH, CH2, CH3. These two has same molecular formula but different in what we have written. See, it's 1-butene, it's 2-butene. Here this position is about double bond's position is second, now it's become is first. This is called as position isomers. Next, what about functional isomers? Functional isomers. Here in these functional isomers we have certain things you have to remember. That is, we have yesterday learnt about functional isomers, how they are named, and I have given that sheet also in my Instagram ID, you can check it out. What is that? If here alcohols and ethers are functional isomers, that is, you can see here with an example, OH. This is called as alcohol, ol, right? Now about ethers, these both have same molecular formula but it is of ROH form, it is of ROR form. R means CH3 CH2 here R means CH3, R means CH3, okay, which have same molecular formula but here the representation of functional groups are different. Here we are representing it as alcohol and here we are representing it as ether. Like this, following four you should be remembering because it is very important. Isomerism is very important chapter for all competitive exams. Aldehydes and ketones, CH3, CH2, CHO and CH3, C double bond O, CH3. Examples: See, aldehydes. Here we have this is aldehydic group and this is ketonic group. So this is having same molecular formula with this, but we have written it in this form. It is aldehydic form and it is ketonic form. So that is called as functional isomers. And remaining I will be writing it. You can note it down. Carboxylic acid and esters, CH3COOH and CH3O C double bond OH, cyanide and isocyanide, CH3C triple bond N and CH3N triple bond C. This is just reverse of Cn. Okay. Now this comes into structural means functional isomers. Next, following in this following only. This is following. I am telling it next. Next is metamers. I'll change the color of pen. Metamers. Metamers. Now, what are metamers? If you write ethers only, metamers, you can change that it's a type of ether, but in oxygen if you can say it as ether, but when it is changing to nitrogen you can't say. So metamers examples: CH2O, CH2, CH3. Here position, you can see the position. Now when CH3, CH2, CHO, CH3, you can see the difference. Here the position of oxygen is second position, but here it is becoming third. So this change, such a change is called as metamers. Okay. Next comes to the most important topic, most important isomer, tautomers. If you comment it about this, I will make separate video about this also, because it's such important. Tautomers, this is explained in the form of difference in electrolytic substitution, electronic distribution and position of middle atom, mobile atom, sorry, because means the one atom, such as hydrogen, will be moving from one place to another place. With an example, see X, Y, double bond Z, X double bond Y, Z, H. Here also we have H. In this, how it became like this? 1 minute. Here you can see this bond is migrated this side, this bond is migrated this side, and this hydrogen migrated this side. This is called as up like this, it flipped like this, and this hydrogen here when it came, it has become extra, so it has left to where it should. There, here it is empty, so it has left here. This is called as tautomers. I will give one more example. See, diene and phenol. Here diene means, this is the molecular formula, and phenol, we know that it is a type of benzene ring, and OH. Here you can see this bond is migrated here we have hydrogen, right? This hydrogen here, it is migrated to here, and this OH is migrated here. This is most important example. Here mostly in nature we will be seeing this only, because it is stable, it is aromatic. Aromatic means stable compound. This non-aromatic, so it is non-stable. This about aromatic and non-aromatic I will be explaining in detail in further session. Next, we know about enolic content, right? What is enolic content? Before that, isomers exhibit simultaneously in equilibrium with each other. This in tautomers, isomers both exhibit in simultaneously, means in which form is stable, that will be wholly, it will be there in nature, but which is these forms will be migrating that side, this side, that side, this side, like that examples I will be giving now. See, you want me to write that statement, then isomer exists simultaneously in equilibrium with each other. Okay, yeah. Okay. Then I'll be giving that examples now. CH3, CH2, C double bond O, CH2. This can be migrated like this: CH2, C, OH, double bond CH2. Same thing here also. Double bond here, hydrogen here. Okay, same example. Keto forms. So yeah, one more thing. Keto forms, C double bond O, CH, support any groups. This can be converted into alcoholic groups. OH double bond C, C. Here bond for keto forms, bond energy is high than alcoholic groups. Bond energy is high than alcoholic groups, so this will be more stable. We will be seeing in most of the cases this form only, not this form. This form only will be seen, but it will be flipping like this simultaneously. This two will be occurring. Keto form is more stable than this enol form. Enol form, you know, this is what is enol form means. In this only I will explain it. See, this is en, this is ol. So combinedly we will be telling enol form. This is enol form. In tautomers you will be considering this enol form. Okay, yeah. This is about our structured isomers. Now coming to stereoisomers. I think so. Stereoisomers I should take 2 sessions. Yes. Okay. In stereoisomers, this is one of the most important topic in whole organic chemistry. Listen it carefully. Stereoisomers. In the stereoisomers, first is geometrical isomers. Some molecular and structural formula, same molecular structural formula but different positions. See how it will be there means, this is also having, again, geometrical isomers also has cis and trans form. I want definition I will be writing same molecular and structural formula also. Before in structural isomers you will be changing in structure, but in stereoisomers, first one geometrical isomers. In this geometrical isomers, same molecular formula and structural formula also, but different positions. This is most important. Okay. First one in this, cis and trans. What are cis and trans? When this will be for enes only, hydrogen Cl, hydrogen Cl. Two more electronegative atoms or two more mass atoms, means two same atoms will be only in one side, then it is called as cis. If two same atoms are of opposite side, like this, two will be of opposite sides, like this. Here H, here Cl, here Al. Then it's called as trans. This is cis. This is one type of in geometrical isomerism. Next comes with syn and anti. anti. What is syn and anti? This is also same type as it of cis and trans, but you will be having slight difference. You can see like this. Here other group may be present or may not be present. It may be same or may not be same. Here you can see it's both phenyl groups. Here it has more mass, but here nothing is present, but it is in same side. In same side. This is here empty orbital, but it's in same side. Here we know it has lone pair, right? But it is in same side. So this is syn type of cis. Here C6H5. This is phenyl group. C6H5. Here we have this lone pair. Here we have this lone pair. But here it is in opposite side. So it is anti. Syn anti. Okay. This is called syn anti. Now, some important topic about cis and trans. Listen it carefully. This is one of the important topic. Cis, trans. Okay. Here, melting point. Which has more melting point and which has less melting point? In melting point, trans has more melting point. Tick means more. Okay, trans has more melting point. Coming to boiling point, cis has more boiling point. Coming to stability and dipole moment, refractive index, viscosity, this all cis only has more. Again, sorry, stability only trans will have. This for cis only has more. Here we can see trans will be ahead in melting point and stability. Rest whatever may it be, rest all it is cis only. Remember, melting point and stability will be more for trans, rest all it will be more for cis only. This is one of the important topic here. You should note it down. Okay. Next, here now E and Z configurations. E and Z configurations. What are E and Z configurations? E is again same as cis form and Z is again same as trans form. When four different atoms, here see it, here both are same but of different side, here same side, this is over. Now E and Z, when four different atoms are grouped attached one on one carbon, then when four different atoms are attached to carbons like this, here Br, here I, here F, here Cl, here we can see these both have more atomic masses than these both. See, these both are on one side, then it is called as E, type of cis. And this I, Br, F, Br, here Cl, then it is Z. This is type of trans. These are EZ configuration. Four atoms, four different atoms, here no two are same, four different atoms are attached, then we will be saying this EZ configurations. Now, in next session I will be discussing about conformation isomerism and polarizing light, electromagnetic effects, and plus C effect, minus C effect, inductive effect, electron displacements. This all I will be discussing in next video because it is becoming too long, so I'll be closing here. So thanks for watching till this here. I think so you have enjoyed, so please subscribe, like and share this video. Remember, daily I will be uploading one video, so join our channel. Thank you.